Hello, computer science students. Welcome back to our third assembly video. In this video, rather than creating a new program, we're going to focus on debugging because we're about to enter programs that require more logic. So how do we debug? How do we find problem logic errors? How do we find other errors, runtime errors, as we run our programs? Well, we use that. We're going to do that with the help of a debugger called GDB. So you can see here we've only completed 2 programs, and we're going to run one of them through the debugger. So once you have created a program, assembled it, linked it, and have your executable, you can run GDB, and then space, and then whichever program it is that you would normally like to run. So this will run your program in the debugger. So when you run this, you'll see a lot of information pop up, links to instructions, GDB manual, information about it, all that's good and well. And really what it means is that now we're in the debugger and we're able to start running. So how are we going to use it? We could just type RUN and hit enter to run it. However, without any breakpoints, without any other information, that would be basically the same as just running the program and would not help us get any extra information. So instead, what we're going to do is create a breakpoint. And we usually like to use labels for our breakpoints because this allows us to control and see how our program works, and usually labels are great for this. So the start label in this case is all we have, and so we're going to create a breakpoint at our start label. What that means is once we run our code, it will stop at the start label and allow us to start controlling the program, seeing what inputs and outputs are, and monitoring what happens, seeing where and when things break. So let's run it. We have now started our program, and once we have started it, we have run into our breakpoint at the start marker. Now, since we're in assembly, we care about registers, which would not normally be easily visible or available, but if we would like to, we can see them using layout reg. So you'll see me type layout space reg. This means that I want the layout of my debugger to show the registers. And so if I hit enter, you'll see that the window changes. It shows you registers R0, R1, R2, R3, R4, R5, R6, even through registers that we cannot edit, but just in case you wanted to be able to reference them. It also shows our assembly code where we are in our program. In fact, you'll see this first line that says _start is highlighted because we are about to run this command. We have not run it yet, but we're about to. So the thing that's highlighted is the command we're about to run. And so if you look and think back to our program 2, we put 50 in register 1, 60 in register 2. We added 50 and 60 together and put the result in our return register, register 0. Then we told the program we are going to exit by returning an integer, which is why R7 has the value 1 in it. And then we have our system interrupt. These commands all have been modified just slightly by the computer to allow it to translate directly to machine code. But the commands that we wrote there should be pretty clear and obvious. And so it's time for us to start walking through. So how do we walk through our program? Next I stands for next instruction. So if I type next I and hit enter, that means I'll run the next instruction, the one that's highlighted. And we can see the result reflected in the registers above. We see that the value 50 has been saved in R1. If you really want to abbreviate this, you can just do NI for next instruction. In fact, that's what you'll see me do most of the time. And so now that we've saved 50 in register 1, we can save 60 in register 2 with NI. And sure enough, that works. And in fact, just to fully go through all the abbreviations and shortcuts in GDB that may be helpful here, if you just hit enter with typing nothing, it will run the last command you ran again. So if I hit enter again, that will execute the next instruction again. And so this is really the shortcuttiest way to go through. And so our next instruction was to save R1 plus R2 and save that result in R0. So we took 50 plus 60, added them together, got 110, and stored that result in R0. So there you go. Our program has finished executing, except that we still need to exit. So I'm going to hit enter again. We moved the value 1 into register 7, and now we are going to complete our program. So you can see that when I ran that last command, that SWI0, that ended our program. And in the debugger, that basically says our process has exited with code 0156. We've finished the state of the thread, and we can't debug anymore, which makes sense. The program's done. So do you want to quit the debugging session, yes or no? At this point, the answer would be yes. And we hit enter. We don't need to create a core file GDB. And so we are done with our debugging process. So this is a really good way to create breakpoints at labels, run your program, step through it line by line to see where errors occur, and figure out if you have logic errors by checking values in registers and things of that nature. So most of our future programs we will run just using GDB, so we can make sure we see everything that's happening. All right, I will see you guys next time.